Ladies and gentlemen, as we cross the milestone of 50, our nutritional needs evolve subtly yet decisively. The body doesn't stop functioning, but it begins to require smarter fuel. Among the most debated of these fuels, nuts. Nature's tiny powerhouses, yet here's the paradox: some nuts can extend your life, support your brain, balance your hormones, and others. They can quietly sabotage your health if you're not careful. Let's begin with the truth few acknowledge: nutrient density after 50 isn't a luxury, it's a necessity. Our cells don't regenerate as efficiently. The gut doesn't absorb like it used to. Bones get porous. Brains fog. Muscle shrink. The right nutrients in the right forms at the right times. This is the art of aging well. And nuts, when wisely chosen, deliver micronutrient payloads that can rival some multivitamins. But what truly separates the good from the risky? It's about balance. Your body's inflammatory balance is a delicate scale. Some nuts, like walnuts, are rich in omega-3 fatty acids, helping reduce systemic inflammation. But others, like peanuts, are packed with omega-6 and low in omega-3s. That imbalance fans the flames of inflammation, the root of arthritis, cardiovascular issues, and cognitive decline. And it's not just about fats. Neuroprotective compounds matter too. Almonds and pistachios, for example, contain polyphenols and antioxidants that nourish your brain's memory centers. They stimulate BDNF, the brain's own growth fertilizer. They fight off oxidative stress, one of the main accelerators of mental aging. But here's the danger zone: not all nuts are safe across the board. Some contain mycotoxins, naturally occurring molds that quietly burden your liver and immune system. Cashews and peanuts, especially when improperly stored, are frequent offenders. Others, like Brazil nuts, while rich in selenium, can tip into toxicity with even moderate overconsumption, impairing thyroid function and cellular metabolism. Let's also talk about the gut, because digestion after 50 becomes a new battlefield. Certain nuts are coated with antinutrients like lectins and oxalates that irritate the gut lining, inhibit mineral absorption, and in sensitive individuals provoke autoimmune responses or kidney issues. The body's detoxification pathways, less robust with age, can struggle with these compounds. And perhaps most importantly, nuts are hormone modulators. Macadamia nuts and almonds, for example, are rich in healthy monounsaturated fats that aid in preserving testosterone and estrogen balance. This isn't vanity, it's critical. Balanced hormones support bone density, libido, muscle retention, mood, and sleep. On the flip side, nuts high in omega-6 and low in antioxidants may increase aromatase activity, converting testosterone into estrogen, worsening metabolic issues in both men and women. Finally, it all comes down to timing and quantity. Eating nuts in small amounts with meals supports satiety and metabolic health. But over-snacking, even on healthy options, can spike insulin, add excess calories, and create oxidative stress from over-roasted oils or sugar coatings. So what should you do? Prioritize 4 nuts that help you thrive: walnuts for brain, heart, and inflammation support, almonds for antioxidants and metabolic health, pistachios for blood sugar balance, and lutein for the eyes, macadamias for healthy fats that stabilize hormones and energy. And be cautious of these 4 risky picks. Peanuts, due to mold exposure, high omega-6 and gut irritation. Cashews, high in oxalates and often overprocessed. Brazil nuts, easy to overdose on selenium, flavored or sugar-coated nuts, stealth sugar bombs that hijack metabolism at the age of 50 and beyond. It's not about eating less, it's about eating right. Nuts can be your allies or your adversaries. Know the science, respect your biology, and make food work for you. Because thriving isn't luck, it's a strategy. Nutrient density dictates functional longevity, because as the body ages, its ability to extract, absorb, and utilize nutrients becomes less efficient, while its need for those very nutrients becomes even more critical. With every passing decade, physiological systems such as digestion, cellular repair, and hormonal regulation start to slow down or become more selective in how they function. This means that every bite of food consumed needs to deliver a higher return on investment in terms of micronutrients, antioxidants, essential fats, and bioavailable compounds that support tissue regeneration, cognitive resilience, immune integrity, and metabolic precision. Nutrient-dense foods, like the right kinds of nuts, become foundational tools in supporting neuroplasticity, reducing oxidative stress, optimizing mitochondrial function, and sustaining the complex interplay between muscle maintenance, bone remodeling, and cardiovascular stability. Unlike calorie-dense but nutrient-poor foods that provide fleeting energy and long-term damage, nutrient-dense options actively engage with genetic expression pathways, promote anti-inflammatory signaling, and help buffer against the cumulative wear and tear imposed by environmental toxins, stress, and metabolic shifts. They provide the building blocks needed for everything from neurotransmitter synthesis and hormone modulation to collagen production and immune surveillance, allowing the body not just to survive, but to adapt, repair, and perform with vitality well into advanced age, which is why the consistent inclusion of foods packed with vitamins, minerals, and bioactive compounds becomes a cornerstone of long-term resilience and cellular optimization. Omega-3 to omega-6 ratio drives inflammation or recovery because these two classes of essential fatty acids compete for the same enzymatic pathways in the body, and the balance between them determines whether your internal environment becomes pro-inflammatory or anti-inflammatory. Omega-3 fatty acids, particularly EPA and DHA, are renowned for their ability to support cardiovascular health, improve neuronal membrane fluidity, reduce systemic inflammation, and even influence gene expression related to longevity and repair mechanisms. Omega-6 fatty acids, while essential in small amounts, become problematic when consumed in excess, especially in their highly processed forms found in seed oils, packaged foods, and some commercially prepared nut products. An imbalance often seen in Western diets where omega-6 intake can exceed omega-3s by ratios of 15:1 or higher shifts the body toward chronic low-grade inflammation, which is a known driver of age-related diseases such as arthritis, atherosclerosis, type 2 diabetes, neurodegeneration, and even certain cancers. This imbalance affects cell signaling, hormonal cascades, immune responses, and tissue regeneration, often leading to increased oxidative stress and a compromised ability to repair or maintain tissue integrity. In contrast, a balanced or omega-3 dominant ratio can promote resolution of inflammation, enhance endothelial function, support synaptic plasticity, and preserve muscular and cognitive capacity as the body ages. Certain nuts, like walnuts, naturally favor a healthier omega-3 to omega-6 ratio and help tilt the body's inflammatory tone toward healing and recovery, while others like peanuts and cashews can exacerbate omega-6 dominance and push the body into a prolonged inflammatory state if not counterbalanced by sufficient omega-3 intake from diet or supplementation. The ratio also modulates eicosanoid production, molecules that influence pain perception, immune signaling, and vascular tone, making this dietary balance a key regulator of how the body responds to internal stressors, tissue injury, immune challenges, and the metabolic demands of aging. Neuroprotective phytochemicals delay cognitive decline by interacting with key molecular and cellular pathways that preserve neuronal health, enhance synaptic function, and combat the oxidative and inflammatory stressors that accelerate brain aging. As the brain matures beyond midlife, it becomes increasingly vulnerable to insults from free radicals, glycation end products, reduced blood flow, and metabolic dysfunction, all of which contribute to the gradual erosion of memory, attention, processing speed, and executive function. Phytochemicals, naturally occurring compounds found in certain nuts such as flavonoids, polyphenols, sterols, and carotenoids, exert powerful protective effects on the brain's structure and function by upregulating endogenous and antioxidant enzymes like superoxide dismutase and glutathione peroxidase, which neutralize reactive oxygen species and minimize cellular damage. These compounds also modulate signaling pathway like the NRF2-ARE axis and inhibit pro-inflammatory mediators such as NFJB, both of which are crucial in maintaining neuronal integrity and preventing neuroinflammation. In addition, phytochemicals can stimulate the production of brain-derived neurotrophic factor, BDNF, a key growth factor that supports the survival and plasticity of neurons, enhances synaptic transmission, and fosters the formation of new neural connections. Critical processes that decline with age but are essential for memory retention, learning ability, and mood regulation. Certain nuts, like pistachios, almonds, and walnuts, contain concentrated levels of these neuroactive compounds, which help maintain the structural integrity of neuronal membranes, preserve mitochondrial function, and even encourage angiogenesis within the brain, thereby supporting adequate oxygen and nutrient delivery. These effects are cumulative and dose-dependent, meaning that regular, moderate consumption of phytochemical-rich foods can offer long-term cognitive protection, reduce the risk of neurodegenerative disorders such as Alzheimer's and Parkinson's disease, and maintain mental clarity and resilience in the face of age-related neurological decline. Mycotoxins, lectins, and lates, the silent saboteurs, are naturally occurring compounds or contaminants that can quietly undermine health over time, especially in individuals over 50 whose detoxification capacity, gut integrity, and renal function may already be compromised due to age-related physiological shifts. Mycotoxins are toxic secondary metabolites produced by certain molds, often found in improperly stored nuts such as peanuts, pistachios, and cashews. These invisible toxins, like aflatoxins, are potent carcinogens and immunosuppressants that can accumulate in the body and contribute to liver stress, inflammation, and mitochondrial dysfunction. While regulatory agencies place limits on allowable amounts, chronic low-dose exposure can still exert cumulative negative effects, particularly in those with already burdened liver pathways or compromised immune resilience. Lectins, on the other hand, are plant proteins found in many seeds, nuts, and legumes that serve as natural defense mechanisms against predators but can bind to the gut lining in humans, disrupting the integrity of the intestinal barrier. This binding may lead to increased intestinal permeability, also known as leaky gut. which in turn can contribute to systemic inflammation, food sensitivities, autoimmune reactivity, and nutrient malabsorption. Aging amplifies these risks as the gut microbiome becomes more sensitive and the mucosal immune system less efficient at repairing damage or responding to antinutrient load. Oxalates, naturally found in high concentrations in foods like almonds and cashews, are sharp, crystalline compounds that can bind with calcium to form kidney stones or deposit in tissues, leading to joint discomfort, urinary tract irritation, or inflammation in genetically susceptible individuals. When not properly metabolized or excreted, oxalates may also interfere with mineral balance, especially magnesium and calcium absorption, which are vital for muscle function, nerve signaling, and bone integrity in aging adults. How do we? While the effects of these compounds may not immediately felt, their subtle and chronic interference with key physiological systems can gradually contribute to fatigue, brain fog, digestive issues, and increased susceptibility to illness, particularly in those who consume large quantities of nuts without being aware of the hidden compounds they may harbor. How do we? And in those with existing gut, kidney, or immune vulnerabilities who lack sufficient detoxifying enzyme activity or microbial diversity to buffer their impact. Hormonal modulation through dietary lipids is a critical yet often overlooked mechanism by which nutrition directly shapes the endocrine system, influencing everything from energy levels, muscle retention and fat metabolism to mood stability, libido, and bone density, particularly after the age of 50 when hormonal shifts become more pronounced and impactful. Lipids, especially those found in nuts, play a pivotal role in the synthesis of steroid hormones such as testosterone, estrogen, progesterone, and cortisol, all of which are derived from cholesterol and rely on a steady supply of high-quality dietary fats to maintain optimal production. Monounsaturated fats abundant in nuts like almonds, macadamias, and hazelnuts have been shown to support hair ratios of anabolic to catabolic hormones, meaning they help sustain muscle building and tissue repairing processes while keeping stress-induced hormone cascades in check. These fats also aid in improving insulin sensitivity and modulating leptin and ghrelin, the hunger and satiety hormones, thereby supporting metabolic regulation, body composition, and energy homeostasis. Meanwhile, polyunsaturated fats, when appropriately balanced, such as the omega-3s in walnuts, contribute to anti-inflammatory signaling and positively influence hormonal feedback loops through their impact on cellular membrane fluidity and receptor responsiveness. On the flip side, excessive intake of omega-6 rich fats from certain nuts, especially when roasted in seed oils or consumed in large volumes, can disrupt hormonal balance by elevating prostaglandin activity, increasing systemic inflammation, and encouraging the conversion of testosterone into estrogen through aromatase enzyme stimulation, which can accelerate muscle loss, fat gain, and metabolic dysfunction in both men and women. In women, especially post-menopausal, the right fats can aid in supporting estrogen metabolism and adrenal function, while in men, dietary lipids are directly tied to preserving free testosterone levels and maintaining vitality. The hormonal effects of dietary fats also extend to the thyroid, as fats influence the conversion of T4 to the more active 3 hormone, which governs metabolic rate, cognitive speed, and temperature regulation. Furthermore, dietary lipids assist in the transport and absorption of fat-soluble vitamins such as A, E, and K, each of which interacts with endocrine signaling pathways in ways that reinforce cellular resilience and hormonal harmony. Thus, the type, quality, and balance of dietary fats consumed through nuts have a profound capacity to recalibrate hormonal rhythms, buffer against age-related hormonal decline, and provide foundational support for endocrine health at every level of the aging process. Timing and dosage control gene expression pathways because the human body operates on tightly regulated biological rhythms. Circadian, ultradian, how we and metabolic that determine not just how nutrient-absorbed, but how they influence cellular behavior, hormonal signaling, and genetic transcription. When and how much of a specific food is consumed can dramatically alter its physiological impact, especially after the age of 50 when metabolic flexibility declines, hormonal regulation becomes more sensitive, and cellular repair processes slow down. Nutrients derived from nuts, such as polyunsaturated fats, amino acids, polyphenols, and micronutrients like magnesium and selenium interact with transcription factors and molecular switches like AMK, SRT1, and MTR, which govern energy balance, autophagy, inflammation, and longevity. These nutrient-sensitive pathways respond differently depending on the timing of ingestion, fasted state Vs, fed state morning Vs, evening, as well as the dose delivered at a given time. Small, measured portions of nutrient-dense nuts consumed during periods of insulin sensitivity, such as earlier in the day or post-activity, can enhance mitochondrial efficiency, support anabolic repair, and reinforce the oxidant defenses, while excessive or poorly timed consumption, particularly at night or in a chronically fed state, can overwhelm metabolic signaling, promote lipogenesis, and blunt beneficial autophagic processes. Gene expression is not not static. It is dynamically influenced by environmental cues, including nutrient availability, caloric density, and meal timing. This means that moderate nut intake aligned with the body's natural repair windows can support the upregulation of genes involved in detoxification, DNA repair, neuroplasticity, and inflammation control, whereas indiscriminate consumption, especially of roasted, salted, or sugar-coated nuts, can activate genes associated with stress responses, metabolic dysregulation, and pro-inflammatory cytokine production. Moreover, timing and dosage affect not only systemic metabolism, but also the gut microbiome, which in turn regulates epigenetic expression through microbial metabolites, such as short-chain fatty acids that influence histone acetylation and methylation patterns. By respecting the body's internal clocks and nutrient thresholds, dietary intake becomes not just a source of calories, but a form of information, an epigenetic mess that tells cells when to build, when to clean, when to rest, and when to regenerate, making the strategic consumption of nuts a potential tool for optimizing cellular signaling, metabolic health, and longevity on a molecular level.